Hello there, children. Today, we're going to work on section 4.5, graphing other trig functions. This educational experience is brought to you by your teacher of trig, that would be me. Now, the other trig functions, we're going to start off nice and simple. We're going to go tangent and cotangent to start off with today. So let us begin. Alright, so to graph tangent, remember the unit circle definition of tangent is y over x. So let's graph it. Now I'm going to go for my 5 pretty points again. They seem to work for sine and cosine, so they're probably going to be a great addition to this. So let's begin. So, at 0 degrees, I have a y-coordinate of 0 and an x-coordinate of 1. Alright, that's going to give me 1. On the bottom, 0 on the top. 0 divided by 1 is just 0. Swell. Alright, starting off with a bang. Now I'm going to mark my tick marks here. Now I'm going to leave myself some space as well, just so I can get nice pretty pictures here. Alright, so we'll go pi over 2. Now the pi over 2 on the unit circle, remember the y-coordinate is 1, x-coordinate is 0. So I get 1 divided by 0. I can't divide by 0, so I get undefined. And how do we write something that's undefined? Remember, if you recall, we go for an asymptote. Alright, let's hope this graph gets a little better. Pi, we go the y-coordinate of 0, x-coordinate of negative 1. 0 divided by negative 1 is 0. Okay, I'm sensing a pattern here. Boom. 3 pi over 2. Why, that gives me a y-coordinate of negative 1, but an x-coordinate of 0. Oh, boy. Oh, man. I see where this is going. Look here. Undefined again. Another asymptote. Okay. Not exactly super helpful yet. And 2 pi, remember, is the same as 0. Gets me 0 over 1, which is a 0. Okay, so this is grand. I have a bunch of zeros and a bunch of asymptotes. That's stellar. So what do? I'm going to go for some other values on my unit circle for a t-chart. Now, off the top of my head, I do recall, however, the following fun fact. Theta, I'm going to pick some other ones. Now, why am I going to pick some other ones? Because I know tangent is y over x. So let's say I go for pi over 4. Now, usually we don't go for pi over 4 because it's root 2 over 2. Except the x and y coordinate are root 2 over 2. They're both the same thing, and something divided by itself is just 1. So right in here I have pi over 4, and I get 1. Well, that gets me a better picture. All right. Going strong so far. Then I go for the next one. Well, we'll try, maybe give it a whirl. We'll go 3 pi over 4. That gets me the y-coordinate again of 1, x-coordinate of negative 1. Something divided by itself is 1, and there's a negative version of it. 3 pi over 4 is right in here. Okay. And you see what's happening here. We'll go 5 pi over 4 just to get you a good look. They're both negative, so that gets me a positive 1. At this point, the game is afoot. And I can graph this. I'm going to play connect the dots. If you need one more for yourself, just to be on the safe side if you're a little worried, you go 7 pi over 4, which again is negative 1. 7 pi over 4 is right there, in between 3 pi over 2 and 2 pi. All right, so let's figure this one out. So I go ahead and plot these. Marked it wrong there. All right. Now we connect my dots. I cannot cross the asymptotes. Remember, they are the MC Hammer of mathematics. So I go up here, catch my point. I go up like this, get close to my asymptote, and down like that. Now remember, I am drawing one 2 pi viewing window here. It kind of looks like that. Now, this would extend down this way, but I need to put another asymptote there. And this would extend up this way, but I have another asymptote at 5 pi over 2. Well, that's interesting. It's an intrinsic fixture indeed. It looks almost like a cubic function, which is very helpful. Some rules about tangent that we need to worry about, though. As you can see, this shape seems to be repeating itself over and over and over again, which is going to change what we talk about our periods. Some notes about tangent. It has a period of pi. If you noticed, it made that squiggle there from a pi. It repeated every pi. There were 2 of them there in a 2 pi window. That's period of pi. It's going to repeat itself every pi, unlike sine and cosine, which repeat themselves every 2 pi. And if you think about it, that kind of makes sense on my unit circle, because they're a ratio of x and y coordinates. So things happening in the first quadrant get me the same reaction as in the third quadrant, because a negative divided by a negative makes a positive. Another thing, it has asymptotes, as you clearly found out already. Oh, happy days are here again. They are the MC Hammer of math. You cannot touch them. Do, 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 do. And all our transformations still apply. What does that mean? We still can have period shifts. We still can have vertical shifts. Phase shifting left and right. Amplitude shifting, vertical shifting. Guess what, folks? They all apply, and they all apply the same way that they did for sine and cosine, which is really helpful. That's why we spend so much time on sine and cosine. But we have tangent, and what do you call 2 gentlemen that go to the beach? 2 tangents. Get it? No? Okay. Anyways, we're going to work on cotangent right now, the basic shape of cotangent. Now it's time to go over cotangent, which is x over y. Again, I'm going to try for my 5 pretty points, and maybe, well, we already know I'm going to have some asymptotes in there, so let's just get this out of the way right now. At 0 degrees, I have 1 as my x-coordinate, and 0 as my y. Well, in this case, unfortunately, it's undefined. Now, here's where it becomes a little tricky, folks. You don't have to put a dotted line here, because that's usually your axis. But realize if a graph shifts to the right, to the right, to the left, you're going to have to make that dotted line move. All right, pi over 2 is 0 over 1, which equals 0. So let's go ahead and get myself those wonderful values and get them going right now. Get them percolating a little bit. Now, it's going to look a little different than what I had. So pi over 2 is 0. At pi, I have, I don't know, negative 1 over 0, which is undefined. At 3 pi over 2, I've got 0 over negative 1, which is 0. And at 2 pi, it's going to be the same as what happens at 0. So, as you notice, my asymptotes go in a different spot. Just like sine and cosine had different particular values. So I have an asymptote at 0, pi, and 2 pi. So let's get those working a little bit. Sound effects optional. And let's go ahead and plot these points. Boom, there's a 0. Boom, there's a 0. Now, that's all well and good, but again, I'm going to have to create another secondary t-chart just for my own purposes. You don't have to do this every time, folks, but for right now, I am just curious to see what shape this does. Again, we didn't make a t-chart for sine and cosine every time, if you remember. We knew the general shape and then just moved it. That's what we're going to do here, but let's build that general shape first. So pi over 4, that's going to get me 1, like we found last time. Because again, what's nice, it's x over y, it's still dividing the quantities. It doesn't matter the order of them, because when I pick pi over 4, it's the same x value as a y value. So that's 1. Bam. Now, the next point I'm going to try to pick here is I'm going to try to pick a wonderful and glorious value that's somewhat helpful for me. I am going to pick 3 pi over 4 because I know in my heart of hearts that that's a point in between here, And I pick 3 pi over 4 because I know it has the same x and y value. Now granted, one's negative, one's positive, but dividing those two things makes it similar. You could go ahead and use things like pi over 3, pi over 6, but you got to remember, you've got a root 3 over 2 and dividing it by a 1/2 at some point. Unless you know what root 3 is off the top of your head, and I don't really expect you to, you're not really going to be able to plot that efficiently. It's right there. And I think you get what's going on, but we'll keep creating the t-chart just in case. All right, we get 5 pi over 4, which is 1, because I get negative root 2 over 2 divided by negative root 2 over 2. So as you can see, here is what's happening. Now notice the difference between the two graphs. They go in opposite directions, not a coincidence. They go the opposite directions that my tangent graph does. The same way sine and cosine flip around, if you thought about it. This is one period right here from 0 to pi, because look, it repeats itself. That's why the period is pi. Now, we'll work on this in class together, moving them and shifting them around, and then we will get to the secant and cosecant graphs, which are a little bit different than these. They go back to our sine and cosine. So, oh happy days are here again. You may go henceforth and do. Oh yeah.